f is in L, I'm just going to abbreviate it, and lambda of E, we'll define it by as the integral on E f d mu. That can be positive or negative, because f can be positive or negative or both, where E is as an element in sigma algebra. So show that lambda of E is greater than or equal to 0 if and only if, this is true for all E. So for all E in X, lambda E is greater than or equal to 0 if and only if f is greater than or equal to 0 mu almost everywhere. So let's do one direction. Here the trick is to check that a number, think of a number is great, forget about the function. Think of this fact, a number is greater than or equal to 0 if and only if, any number that you can think, if and only if that number is greater than, so actually let's do it the other way around. A number is less than 0 if and only if the number is less than
or equal to 0 and doesn't equal 0, is that what you're saying?
No. Just like x less than 0 if and only if x is less than a number of the form -1 over n. No, I mean, if and only if there is an n such that the number is less than -1 over n. Does it make sense or not, guys? Because if there's an n such that x is less than -1 over n, and because this is less than 0, by transitivity, x is going to be less than 0. Now, the other way around, if x is less than 0, here is 0, here is x. So the numbers -1, or -1 is here, -1/2. At some point, you get -1 of n. At some point, x is going to be less than -1 over n. Do you guys agree? So that's true. Based on that fact, you consider the set A equals the points in the universe such that f of x is less than -1 over n. All right? And we applied the usual technique. We're not going to write, we're only going to watch and then you write it, okay? Here we go. So what happens on A? On A, what happens? Who's bigger? F of -1 on A. For x in A, what happens? On A, f of f is less than -1 over n, right? On that set, in other words, for x in A, f of x is less than, yes or no?
Yes.
Therefore, in general, the technique is hence, in general, multiply, this is true, multiply by the characteristic function of A, and that's true regardless. You see what I mean? Yes? That's called the technique. You build a set, and on that set something happens, you say therefore in general it's true. Now that this is true, you take integrals in both sides. Right? V mu, oh shoot. V mu is less than or equal than 1 over n times the function of A d mu, right? So you take integrals in both sides. And then this integral is very easy to do. What is this integral? Equal, this is a simple function, this is like a number. Imagine like 5, the characteristic of 2,9. What is the integral of that?
5.
It's 5 times the length of the interval, or the measure of this integral, right? So likewise here, what is this integral? -1 over n times the measure of A.
What was pretty less on
No, it's less than or equal, because when you have a function less than another one, the integral is less than or equal. Because the integrals actually might be equal. So
Okay.
either you have the zero function, you have a function that has only one dot.
So even though we had that strict inequality in the previous step?
Oh yeah, you can look here. It doesn't. This one it doesn't matter.
No.
This one doesn't matter. All right. So, oh, by the way, this integral is what? It's this thingy, right?
Yeah,
You see it?
yeah, it's one of those.
So this is equal to what? The
Right.
integral of f d mu on a, right? This a goes, right? And this is the same as lambda
Okay.
of a. But lambda of a, I'm going this direction, therefore I'm using this as my hypothesis. This guy is greater than or equal to 0. Therefore, this guy is greater than or equal to 0, right? But look at this. This guy is positive or negative?
Positive.
Well, greater
Or
than or equal to 0,
zero.
right?
Okay.
But you multiply by a negative number, this is less than 0. What happens when you multiply a positive number times a negative number? That's less than or equal to 0. Again, by the squeeze theorem, what happened by the squeeze theorem?
Everything is zero.
So everything's 0. So in particular, this guy is 0, right? You agree?
Yeah.
So by squeeze theorem, like this is not 0, so this has to be 0, right? Lambda, no, what? Mu of a equals 0. I didn't want to tell you because I didn't want to scare you, but this set depends on n. You guys agree? I mean, there is an n right here, but if I put the n, people will get scared. Now just think, this set depends on n, right? So this is true on n. Now that you know that, what I know is that all these sets have measure 0. And so it's time to recap, say, what is what I wanted? What is what I wanted? I wanted to prove that f is greater than or equal to 0. And what does this mean? It means there exist, this means what? There exists
What's that?
a set
From measure.
in the sigma graph of measure 0 such that outside of that set, for every x outside of the set, f is greater than or equal to 0, right? Yes? So in other words, I'm looking for a set. I claim that I found it. I found the set. So I found the set. And the set n is equal to the union of all these guys. Now clearly, what is the measure? But why is that? Okay, so 2 items. If I prove this and this, I'm done, right? So 2 items. Number 1, I want to prove that the measure is 0. What is the measure of n? It's the same as the measure of the unions. So let me see 2 items here. And with those 2 items, we'll finish. So first item is the measure is 0. So some people are tempted to write here equals the sum of the measures of an. I say each of them has measure 0, professor, so therefore the whole sum is 0. And you're right. But the question is that that's not true unless they are disjoint, right? We don't know. But what is true for sure is that the measure of any union is less than or equal than the sum of the measures. So it doesn't matter. So this is 0, that forces n to be 0. You see what I mean, guys? Therefore, well, the measure of n is greater than or equal to 0. By the squeeze theorem again, so then by squeeze theorem, the measure of n is 0. And the second item is that I wanted to prove that outside of that, the function is greater than or equal to 0. But that comes from this fact that you agreed at the beginning. That comes from this fact. A number is less than 0 if and only if there exists an n such that x is less than or equal to -1 over n. So this there exists transforms into a union or intersection. Union, right? If you have for all, that's intersection. But this there exists means a union. So therefore, the set of points where the function is negative, by using this fact, is the same as the union. So if something is negative, therefore there exists an n such that what? This just translate that into this union. So f of x is less than 0. Forget about x. You can call it f of x. F of x is less than 0. Therefore, there exists an n such that f of x is less than or equal to negative 1 over n. Now, who the heck is this set? Who the heck is this set? Do you what's the name of that set? an. And who the heck is the union of an? What is the union of an? N, right? The union of an is capital N. Conclusion, what happens on n? What happens on n? F of x is less than 0. And what happens outside of n in the complement of that? F of x is greater than or equal to 0. See what I mean? In the complement of that, hence, we say hence, for x outside of n, outside of this set, the complement of this is the opposite. F of x is greater than or equal to 0. All right? Take a look. We first we write this fact, and this fact you can put it in your in your cheat sheet if you wish. You build a set and you apply the technique. What is the technique? On that set, this function is less than that. Or you can put less than or equal if you wish. Therefore, you take integrals in both sides. One integral
About
is
in being extracted in alcohol, but
That's science, right?
That's good.
I don't know why I started playing.
Music does.
That's weird. Sorry.
so on this set, you apply the usual technique, take integrals in both sides, multiply by the characteristic, take integrals on both sides. This integral is easy. And this, you use the hypothesis. And therefore, by the squeeze theorem, all of them are 0. In particular, this guy is 0. And then you say, I found the set that I was looking for. My set is n equals the union. Why union? Because it says here there exists. Remember, union is associated with there exists. An intersection is associated with for all. You have to remember that, right? Go ahead and try to write it on your own, guys, without looking at the board. And if you cannot, then look at the board and see, oh shoot, I forgot that, okay? In this way, you will be very, very ready for the test.